This video covers section 6 of chapter 1, AP Chemistry. And section 6 is about the units of measurement. So in science, we use SI units, which stands for International System Units. And these are the examples that we use. So for mass, we're going to measure in kilograms. For length, meters. Time is seconds. Temperature is Kelvin. And the amount of something we measure in moles. Okay, and over here we have the abbreviations for those units. The unit prefixes are symbols that modify a unit's magnitude. So if we do not want to use seconds, but we want to measure something much larger, a larger length of time, we're going to use a prefix that takes the second and enlarges it to a greater magnitude. Okay, and here are all of the prefixes. So we have giga, which means a billion, mega, which means a million, kilo, which means 1,000, deci, which is a tenth, centi, which is a hundredth, milli is a thousandth, micro is a millionth, and nano is a billionth. Okay, so those are most of the ones that we use in here. And pico is a trillionth. So when you see that prefix next to a unit, it's changing the magnitude of that unit. So a megamole, for example, means you have 1,000,000 moles. Okay, a mega dollar would mean you have $1,000,000. We all wish, right? Okay, so, and then you have down here milli. A milligram is 1,000th of a gram. So a gram is about a paper clip in mass. And if you had a milligram, it would be that paper clip divided into 1,000 equal parts. So a milligram is a very tiny measurement of mass. Okay, how do I use those prefixes and those units to convert from one to another? In chemistry, we use dimensional analysis, which is just a very fancy way of saying we cancel out the units to change from one to another. And to do that, we use a conversion factor, which is just a fraction where you have two equivalent amounts, one on top, one on the bottom. And you're going to set it up in a way where you have the unit that's given in your problem on the bottom of your conversion factor, and the one you're trying to find goes on the top of your conversion factor. And the best way to explain that is with our example here. So if we were given 35 inches, and the question says how many feet are in 35 inches, then you would set up this equality. We know that 12 inches equals 1 foot. So if I have 35 inches, how many feet is that? So you're going to take the equality of 12 inches and 1 foot, and you're going to set it up as a fraction. So the way we decide what goes on the top and what goes on the bottom is by the units that were given. So if I look at my number that's given, it's 35, and the units that are given are inches. So that's when I took the 12 inches and I put those on the bottom of that conversion factor. And the one we're trying to find, which is feet, goes on the top. Okay, and you guys can see in my example, the inches have canceled out. So I'm left with the units we were asked to find, which are feet. And then I have numerically 35 divided by 12, which is 2.9. Okay, let's look at some metric units. So feet and inches are not metric units, but kilograms and grams are. So in problem 59A in your textbook, it's given that you have 1,245 kilograms. And the question says, how many grams is that? So I'm going to set up my equality here. That tells me that 1 kilogram is 1,000 grams. Okay, and then I have my given number. So take this, we're going to rewrite it over 1. And using this equality, I'm going to set up a fraction. Since these are two equivalent things, this fraction of 1,000 grams and 1 kilogram is actually 1, because 1,000 grams is 1 kilogram. And anytime you have the same number, like 10, for example, over itself, 10, they cancel out to be 1. So this conversion factor isn't actually changing the magnitude of our measurement. It's just changing what units that measurement is in. So kilograms were given, okay, up here, this is my given number. These are my given units. So these kilograms are going to go on the bottom here. And the ones that I was asked for, the unknown, are grams. So grams go on the top right here. Okay, and then I plug in the numbers from my equality. So 1 kilogram, 1,000 grams, and you can see that we're just multiplying it by 1,000. So that means I'm going to have the decimal move 3 places to the right, and I get this big number right here. Okay, and when we have really big numbers in chemistry, it's best to put them in scientific notation. They don't have to be in scientific notation, even on the AP test, but it's just a shorter way of writing it. So you're going to take the decimal, which would be right here after this 0, and you're going to move it to a place where there is only one digit between 1 and 9 on the left of the decimal place. So I'm going to have to move the decimal all the way between the 1 and the 2 so that there's just this 1 to the left of the decimal right there. Okay? And then you count how many places you had to move the decimal to get to that spot. So I would have had to move 1, 2, 3, 4, 5, 6 places to the left. And that's why I get this 6 up here as the exponent. Okay, and when you see a large number like this, you should have a positive exponent up here. If it was a tiny number, you would have a negative exponent, because this means 1.245 times 10 to the 6th is a million. So you have 1.245 times a million, which is going to be a big number. If it was a negative 6, that would be a millionth. So you're taking 1.245 and you're dividing it by a million if that exponent were negative. Okay. Down here, we have this many kilograms, and we want to know how many milligrams are. And this is going to be an enormous number because kilograms are about 2 pounds. And if you have 1,245 of them, you have a huge mass. And remember, milligrams are 1,000th of a paperclip. So how many of those thousandths of a paperclip are in this huge mass? It's going to be a really big number. Okay, so make sure you go through and mentally think out if your answer is logical, if it makes sense. Okay, so I'm going to rewrite my given down here, and I'm going to have 2 different equalities this time because I don't know off the top of my head. I bet some of you do, but I don't. How many milligrams are in a kilogram? But I do remember that kilo means 1,000, so there's 1,000 grams in 1 kilogram. And for milligrams, 1 gram is equal to 1,000 milligrams. Could I say that 1,000th of a gram equals 1 milligram? Yes, that's still an equality. But now I have a decimal where I don't necessarily need one, so I'm making my life a little harder there. So this is just the way I prefer to set it up. Okay. And I have 1,245 kilograms. I want kilograms to cancel, so I'm going to take this and put it down below. I'm going to take my grams and put them up here. And then the kilograms have canceled, I would be at grams. So I want to put grams down below and my final unit that I'm trying to end up with on the top. And I'm going to take this 1,000 milligrams, plug that in there, take my 1 gram, plug it in there. And I am multiplying this big number by 1,000 and by 1,000, which is a million. And so that means I'm going to move this decimal 6 places to the right. Okay. Writing this in scientific notation, I would move the decimal all the way between the 1 and the 2 again, and then I would have to move it 3, 6, 9 places to get there. So that's where the 10 to the 9th comes in. Okay, so this is called the metric slide, and this is just another way to do these conversion problems that might be easier for some of you. It might be just confusing for others. So if it helps you, use it. If it doesn't, you can ignore and use the last way. That's fine. Okay. So to use this metric slide, you have to have this little setup here. Okay. And you can use this in my class. I don't really mind if you guys have this out. And the way that you use it is you're going to start with the prefix with which you are beginning. So let's say that we are beginning with kilo, like our problem said, if we were starting with kilo, we would be right here at 10 to the third power, 1,000, right? And we're trying to get to milligrams right here, 10 to the negative third. Find the prefix for the answer which you are seeking. That was our milli. Number 3, count the powers of 10 on the number line to get from where you start to where you finish. So 10 to the third, 10 to the negative third, that's 6 powers of 10 difference between these two. So that means I'm going to move the decimal 6 places to the right. Okay, I'm going to move it 6 places to the right by a million. Okay, so then in my last problem, instead of writing this out where I'm moving it 6 places, I would just take this. Looking at the metric slide, I would see 6 places to the right, and I would move the decimal 1, 2, 3, 4, 5, 6, and I would get this number down here in one step. Okay. If we were going from micro to milli, so let's say I had 5 micrograms, how many milligrams is that? We are moving from 10 to the negative 6th to 10 to the negative third. I'm moving 3 powers of 10 to the left, so I'm going to move 3 decimal places to the left. So if I said 5, the decimal would be after the 5. I'm going to move it back 1, 2, 3, and I would get 0.005. Okay, if you have a measurement that is in scientific notation, it's the same idea, except that you are going to add and subtract from the exponents. And I'm going to write on this guy. Okay, so let's say that I had, for my example, let's do base unit to micrograms. So if I have 1 times 10 to the negative 4th grams, and I want to change that to micrograms. This is the Greek symbol mu, which means micro. If I'm changing it to micrograms, I'm starting with a base unit of grams right here. Okay, so I start with my base unit of grams, and I'm moving to the right 6 powers of 10, 10 to the 0, 10 to the negative 6. So I'm going 10 places to the right. If you're moving the decimal to the right, the number is getting larger. So you're going to add to the exponent. So it's 10 to the negative 4th plus 6, which is going to be 10 to the 2nd power. Okay, so that would be my answer. 1 times 10 to the 2nd power micrograms for that problem. Okay, let's do this problem down. Oh, I think one of these was supposed to be micro. Let's make this micro. Whoops. Erase this. Okay, so let's make this a microgram, and then we can do this problem. Right? So if I'm going from 7.5 times 10 to the third milligrams to micrograms, milli was 10 to the negative 3, and micro was 10 to the negative 6. So I am moving 3 powers of 10 to the right. I'm going to add 3 to this exponent, and I will get, I'm not going to have enough room here, 7.5 times 10 to the 6th power micrograms. Okay, that would be my answer to that problem. Okay, let's look at this one right here. I wonder if I can change the size of this. Nope, only the color. Okay, so if I'm going from kilo to milli, I'm going from 10 to the third power. Let's erase this. Oop, I could have just erased the exponent, huh? Well, that's okay. So I'm going from 10 to the third power, which is on the left side. And I'm changing that to 10 to the negative third. So 10 to the third, 10 to the negative third, the exponent is changing by a total of 6. And that means I'm moving 6 places to the right. So I'm going to take this exponent here and I'm going to add 6. So I will get 1.92. I'm going to put the times up here. Times 10 to the negative 9 plus 6 is negative third power. Okay, so that's how I would do that one. Let's go from small to big. Let's do this one. So liters would be 10 to the 0 power. Let's erase just this guy. Okay, and we're going the opposite way. So I'm going from 10 to the 0 power to kilograms, which is 10 to the third power. And this time we're moving to the left on our little metric slide up above. So if I was moving the decimal to the left, this number is going to get smaller, and that means I subtract from the exponent. So I'm moving 3 powers of 10, so I'm going to subtract 3, and I get 2.9. Oops, 9 times 10 to the first power, which is 2.9 times 10, which is 29. And you could write either one. That many kiloliters. Okay, so that is metric slide, and those are the units. You know what? Let me go back over that, and I'm going to do dimensional analysis instead. And you guys will see why the metric slide is so cool. It's just one step instead of a lot of steps. However, the dimensional analysis, where you cancel units, will take you all the way through college. You'll be able to cancel units in physics in college, in physical chemistry, all kinds of classes. You'll be able to use that one. Okay. Going back, maybe, and select. There we go. Okay, so using dimensional analysis, if I were to do this problem right here, okay, I would write out my given 8.376 times 10 to the negative 2 nanoseconds. Always put your units, and do that on the AP test as well, because sometimes you don't get points if you don't put those units there. So it's a good practice to be in the habit of writing out the units. Okay, and I know I want nanoseconds on the bottom. Instead of writing out all those zeros for nano, I'm going to use an exponent. So nanoseconds are tiny. There are a billion of them, 10 to the 9th nanoseconds in 1 second. Could I put 10 to the negative 9 seconds in 1 nanosecond? Yes, but again, I don't like that negative exponent there. You can, though. It's not wrong. Okay, and then I've converted it to seconds, but this question wants milliseconds. So I want, now that nano will have canceled out, I have seconds, so I want seconds on the bottom. And how many milliseconds are in 1 second? That would be 10 to the third. There's 1,000 milliseconds in 1 second. There we go. Equals. Okay, So now I have 10 to the third over 10 to the ninth. And you guys remember from math, if I have the same, so I have 10 and 10, I can just subtract the exponents. So this can be subtracted from here, cancel, and this would change from 9 to 6. Okay, so I have this divided by 10 to the 6th power, 10 to the negative 2 over 10 to the 6th. I'm going to subtract that 6 from right here, and I will get my answer, which is 8.376. I'm going to run out of room, times, right here, 10 to the negative 2 minus 6 is negative 8th power. Okay, so that's how I would solve that problem using dimensional analysis. And let's see if it works with the metric slide too. Nanoseconds to milliseconds. Nano to milli. So I'm going from here, nano, to here, milli. And the powers of 10 change by 6, 10 to the negative 9, 10 to the negative 3. So I'm going to move 6 places to the left, which means the number gets smaller, which means I'm going to subtract 6 from my exponent. So negative 2 minus 6, and I will get negative 8. I will get the same answer in a shorter amount of time. But again, this method right here will get you through college, and it will be very useful down the road if you get really good at it now. Okay, significant figures I'm going to go over in another video.